Hello and welcome. Coming to you once again, not quite live from One Take Studios, where today we're going to talk about identifying linear functions. I am hoping that you can see the word line in linear, because that is going to be our keyword of the day. How do we decide if a function makes a line or not? All right, I'm actually going to start with a graphing screen for us today, so I'd like you to take a look at this. All right, so here's my graphing calculator, and this, ladies and gentlemen, is a line. How do I know? Well, line in math talks about a straight line. Curvy lines don't count as lines in math. All right? If it's a circle, it's not a line. But this is something that is absolutely positively straight and continues for all eternity, quite frankly. I have an equation for that. Notice the equation is f of x, or y, equals 2x minus 3, so 2 times x minus 3. So I'm going to show you in the next couple pictures here what happens if we put the 2 and the 3 in different spots. Can it still be a line? So 2 times x minus 3, this is a line. Okay, great. What if, this is not 2 times x, this is x squared. All right, so I've got x squared minus 3. Is this a line? No, absolutely not. It has a definite curve to it. So right now, what have we already learned? If the 2 is an exponent, if I have a number here, I've got a problem. All right, so x squared is not going to make a line, and quite frankly, neither is x cubed or x to the 4th or x to the 5th or any of the rest of those. All right, so we are saying that 2 times the x is good. That's linear. X squared, not linear. All right, what about this next one? What happens? Oh, I switched them. I made 2 the base, and I made x as the exponent. Can I do 2 to the x? Well, I can do 2 to the x, but does it make a line? Ew, no, this is most definitely not a line. So yeah, it's actually an exponential graph in case you were curious. But again, if x is lifted up high as an exponent, this is going to be a problem, and that is not going to be a line. Next screen. What is this? Can you see this? I'm going to move him up a little bit, I think. Oh, not that. That's weird. I just moved something else. You probably can't see it. I'm sorry. All right, so we get this instead. I put the 2 on top, I put the x on the bottom, and then I did a minus 3. Again, I can't arrange it like that. That's a thing, but is it a line? Ew, definitely not. That's got 2 curved pieces, so we're definitely not linear for this one. So I am not allowed to divide my x or my y, because that causes problems as well. Everything with problems. Okay, so now I'm back to a line again. Hopefully you recognize that. And what do we see? Well, I've got 1/2 times x. So what am I saying between these two? Am I saying that you can't have fractions? No. This one has a fraction with an x on the bottom. If I had an x on the bottom or a y on the bottom, that's not going to be a line. But if I have a fraction times an x or a y, that's okay. This, you notice, is a very, very straight line. I also installed the grid on this where you can see it, because one of the things that you're going to see with a line is a very distinct pattern. So if I look at where this green line crosses all these little places right here, how it crosses here and it crosses the graph right there. So think about this. I'm going to start at the origin. And where is the next place where this thing crosses? Well, I'd have to go up 1 box and over 2 boxes. Where's the next place that it crosses? Up 1 box, over 2 boxes. Up 1 box, over 2 boxes. Is this coincidence? No, it's not. Not at all. A line has what's called a constant rate of change. That's what makes it a line. That's what makes it so straight, is that you can always have those same patterns. So by taking these and going up 1 box and over 2 box, I can do that anywhere along this line, and it's always going to be true. So therefore, it is most definitely linear. All right, so let's see if we can kind of put this together and see what we have learned from it. Back to my screen here. All right, I have pulled our very first equation, f of x equals 2x minus 3, and I've created a delightful table to go with that. There we go, there we go. And, well, I just talked about a constant rate of change, where it's always changing by the same amount, and with the graph we can count boxes up and over, and that works. But what if I don't have a graph? What if I just had a bunch of points? Maybe I didn't even know what equation they came from. Could I still decide if it's linear? Absolutely. What is the change to go from -2 to -1? All right, so to go from here to here, -2 to -1, that's an increase of 1. And quite frankly, from -1 to 0 is an increase of 1. And from 0 to 1 is an increase of 1. And from 1 to 2 is an increase of 1. Ooh, that's not going to be an increase of 1. I'll come back to that one. All right, so what about over here? From -7 to negative 5. That's also increasing. How much is it increasing by? It's increasing by 2. Negative 5 to negative 3 increases by 2. Do you see where this constant rate of change comes from? When our x values are changing by the same amount, the y values then are also changing by the same amount, going from one y value to the next. Notice we're not saying that the x's and y's are changing by the same amount as each other, but all of these guys are increasing by 1, all of these guys are increasing by 2. That's that constant rate of change. It's constantly changing by the same amount. Okay, so what about this last point, 4, 5? All right, so check this out. If I go from 2 to 4, that's increasing by 2. If I go from 1 to 5, that's increasing by 4. So think about this. I'm going to stack these guys to make fractions. 2 over 1. 2 over 1. So that's 2 over 1, 2 over 1, 2 over 1, 2 over 1. What would this last change have been? This is an increase of 4. This is an increase of 2. What happens if I do 4 as an increase over 2 as an increase? What happens if I reduce 4 over 2? I still get 2 over 1. So even if I jump multiple points along my line, I can still see that constant rate of change. Because if I simplify this fraction, I'm still increasing ultimately by 2 on my y values for every 1 on my x values. All right, so this is what a constant rate of change would look like on a table of numbers. All right, something else that you may be interested in, maybe not, standard form. Standard form for a line is ax plus by equals c. Standard form, fun and exciting? Probably not. Most equations have a standard form for linear, cubic, quadratic, quartic, whatever. And the standard form, I'd like to say, is the form that you would use if you were having tea with the queen. Very formal. Not always very useful, but very formal. So what does this mean? Well, a, b, and c have to all be real numbers for this to be true. And notice a, b, and c are numbers. They're not actually variables. So like a could be 3, and b could be 14, and c could be 542. Doesn't matter, they're numbers. And on top of that, a and b can't both be 0. So a could be 0 as long as b is not, or b could be 0 as long as a is not. And as long as that's true, this is going to be a line, and this is what a line looks like in standard form. What could that mean? Well, let's take a look at this for a second here. Again, I'm using the same equation as before, but instead of f of x, I wrote y. They are the same thing. So this is 2x minus 3, this is 2x minus 3. Right now, this doesn't look like this. This is a line. We showed it's a line. We showed the graph, and then we showed the constant rate of change, but it's not in standard form. Okay, could it be? What would it take to make this equation look like this equation? Notice what this one has. This has the x and the y on the same side, and then a number by itself over on the other side. Can I make that happen here? I say I can. If I want the x to move over to join the y, I need this whole chunk, this 2x, to go away. So what if I did a minus 2x on the left and a minus 2x on the right? Think about what would happen there. 2x minus 2x, that's gone. Please note this is 1y minus 2x. These are not like terms. I can write them next to each other, but I can't actually subtract them. So what do I have? I have a negative 2x, and this is a positive y, so I'm going to put plus y. How come I put the x first? Why didn't I write y minus 2x? Because I'm trying to make it look like this guy right here. This guy has the x first, and then the y, and there's my equal sign, and oh look, what's over here by itself now? The 3. So if I'm looking at this, I can hopefully now sort of see that this is in standard form. What is a for this particular example? A is the number in front of the x, so for this particular example, a would be negative 2, because this is in standard form. What would the b be? A little bit tricky perhaps. B is the number in front of the y. What number is in front of the y? I don't see one. That's because it's 1. 1 times y is y. So a is negative 2, b is 1, and then c is that number standing by itself, so c would have a value of negative 3. So just because something isn't in standard form doesn't mean that we couldn't put it in standard form and then figure out what A, B, and C would be to go with that. All right, we are going to close up today by having a game. The game is called, are you ready? Sorry, there are no prizes. Is it linear? Is it linear? Okay, are you ready for the game? Is it linear? Round 1. 4x minus 6y equals 7. Is it linear? Yeah. Because it's in a standard form. There's my ax plus b equals c, ax plus by equals c. Yes, this is linear and it's in standard form, so definitely it is linear. That's what you said, right? Okay. Round 2, is it linear? X cubed plus y equals 12. Ooh, I think it could be linear because it kind of looks like that. We get the x, then we get the y, then we get the 12. Were you paying attention earlier? I said before we can't do x squared or x cubed. We can't do exponents because that creates different shapes, things that are not straight lines. So no, this is not linear, and this guy right here, he's the reason why it's not linear. Round 3, dun 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 dun, is it linear? Again, I think it might be. It's got the x first, and it's got the y second, and then it's got the 7 to the 1. Hey, I think we're good, right? Wait a minute. We also said in one of our other examples, we can't divide by the x, which means we can't divide by the y either. I'm dividing by y here. Because of this, this is bad. No, it is something, it's just not linear. So we can't have powers that aren't 1. We can't divide by the x or the y under a number like that. What about this one? Is it linear? Oh, it's got to be linear, right? Wait a minute, but it doesn't look like this one. It's not arranged properly. But it doesn't have any exponents, and we're not like dividing by the x or the y or anything. Is it linear? Did you say yes? Because actually this is. I could put this in standard form if I wanted to. If I were to subtract the 7x, I'm taking a shortcut here, I would have minus 7x, and I would have a positive y, and I would add the 11. Okay, I just took an extreme shortcut there, but I can see that is standard form, so that is definitely linear. Yes, yes it is. All right, round 5, is it linear? What you thinking? It kind of looks like standard form. But we have x times y, oh no, that is going to be not linear. Again, it's something, it's just not a straight line. So you're paying attention hopefully to the things that make it not linear so that we can tell which things are linear. Ooh, how many more do I have? Ooh, last round. Ready? Is it linear? Boom! What do you think? Is it linear? Guess what? It is. It is linear. Do you remember when we said before, where'd it go, that A and B can't be both 0? But what would happen to this right here if B was 0? What's 0 times y? 0. And then this piece would be gone, and it would look kind of like this. If I wanted to see this as a standard form thing, here's how I would look at it. I would say that that is 1x plus 0y equals 4. So 1 would be my A, my B would be 0, and C would be 4. Yes, this is actually linear. Specifically, it's a vertical line, in case you care. Those are the ones that go straight up and down. All right, so if you're not used to this, this takes a little bit of practice. If nothing else, especially if you have a graphing calculator, you can always just type it in and take a look at it. But again, we're looking for straight lines, constant rate of change, and no crazy things happening in between. Okay?